This is exercise 6 of the Maximo Application Suite overview. And in this exercise, we'll be using Health and Predict. To give you some background, an operations manager using Maximo Monitor has just identified a pump exhibiting anomalous behavior. A service request was submitted from Monitor where it was assigned to a technician in Maximo Manage. And with the help of Maximo Mobile and Maximo Assist, the technician repaired the pump before it failed. The pump had a non-OEM O-ring in it, and the reliability engineer would like to see if any other pumps are exhibiting low health or are predicted to fail soon. The reliability engineer is going to use Predict in order to dig deeper into all of the similar pumps to make sure that there aren't any failures predicted to occur before planned maintenance. Maximo Health and Predict are both targeted to the reliability engineer. Together, they provide a view of the current state of an enterprise's assets and project future conditions of those assets. Health and Predict arm the reliability engineer with AI-powered insights to take actions to extend the life of the assets, reduce maintenance cost, and eliminate unplanned downtime. As the reliability engineer, I'll identify assets that need attention, investigate those assets, and then take action to avoid unplanned downtime. In order to get started, we're going to select the health application either from this grid, or if you're in another application, from the right side panel of all of the applications. On the main screen, I can see a universal view of my managed assets in a familiar grid view. And this is particularly valuable to me as the reliability engineer because I can see a mix of both IT data from Manage and OT data from Monitor together in a single view. These assets are all coming from Maximo, but we can connect to other EAM systems as well. Different views of our data can be generated to make it easier to identify our critical assets. And on this grid, I can add and move columns, filter, search, and sort. I can also save different views. I have a view saved for my pump. And if you don't have a shared view already created for you, all you'd have to do is go over to the right side of this table and click search and type in PMPD to find our pumps. After they show up, you can sort them however you would like, and then click on these 3 vertical dots and save as pump group and save. Now whenever you come to your assets, you can go to your saved view in order to automatically have that populate. And I can look at some of these columns that are going to tell me how they're doing. So for example, we have this health score, and this is created within the health application for groups of assets from the scoring tab. But since risk tolerance can vary among industries, asset types, and enterprises, I'm able to custom define the scoring ranges specific to my tolerance levels and then assign them colors. So that's why we have these colored dots next to the numbers. Another column of calculated data that we can look at is the days to failure column, and this comes from a predictive model from the Predict Grouping tab. And I can actually navigate to where this comes from just by the left hamburger menu and then Predict Grouping here. So from this dashboard, I can see that my pumps are all in various states of health, but in general, my OEM pumps are in better health. And this is just from a quick glance at the days to failure column, where all of the OEM pumps have a lot longer until their predicted failure than the non-OEM pumps, which are predicted to fail in about 5 days. Another way that I could view this data is spatially. So seeing how the assets are spatially distributed may assist the reliability engineer with identifying and investigating assets at risk. This is particularly true in the utilities industry. And it's a quick click over in the upper right-hand corner. Rather than seeing these pumps in a list view, we're just going to click into the map icon. And this map view shows that we have pumps all over and they're in various forms of health. And this is really helpful when trying to do an analysis visually. Navigate back to the list view, and I'm going to continue my investigation to determine which assets are expected to fail soon. But I don't have a maintenance plan to address the failure. And the easiest way to do this is by using the Work Queue feature. I'm going to navigate to the left menu and select Work Queues tab on the left tab menu. Work queues are pre-configured views designed to help find what you're looking for and to manage your day-to-day activities. As you can see, there are a few particularly valuable to a reliability engineer who needs to address a specific problem. There are a number of work queues included in Health and Predict, and some of them are specific to Predict, like, for example, assets with a high probability of failure. There's also a work queue for identifying assets in poor health, here with the low health. Then there are some work queues that show assets with missing data, like missing criticality score or missing expected life. These missing data work queues are extremely useful to a reliability engineer as they can help identify gaps in data necessary to create health scores or predictive failure models accurately. I'm going to select the failing before PM work queue to see all of the assets with scores in that work queue. As a reliability engineer at a water treatment plant, it is critical for me to avoid pump failures. And in this work queue, we can see that there are 4 pumps that have a predicted failure before their next planned maintenance date. And they're all non-OEM pumps. And this matches our previous analysis on the dashboard that the non-OEM pumps tend to be in poorer health than the OEM pumps. You can also see the pump here, device 005, which the technician discovered with a bad O-ring. So I'm going to select a different pump in the queue and start to manage our workload for the day, investigating and addressing all of the assets in this queue. So we can see the pump here, the one with the bad O-ring that our technician discovered. This asset detail page is incredibly useful for investigating assets. We can find all the asset information presented on a single page in easy-to-read tables, charts, and graphs. On the top of the page, I see details about my asset and KPIs that give me a snapshot of its current state. For this asset, we have a health score of 64%, which is in our yellow zone. And we can see that it's actually increased health score by 2% since it was last calculated. So that looks good. That looks all right. This asset also has a criticality and a risk score. So the criticality score is at 50% and the risk score is at 82%, which has decreased by 1%. So we can see at the top that our next predictive maintenance is planned for 23 days. However, our next failure is happening in 2 days. So this seems like something that we want to notify the technicians to maybe go do an inspection or maybe create a work order so that we can do the predictive maintenance earlier before failure. There's also this MRR card, and that's maintenance to replacement ratio for the asset. This performance indicator can be the ratio of how much we've spent maintaining the asset over its life as compared with its replacement cost. And in this case, we've spent the equivalent of 0.3% of the replacement cost. Below the KPI sections, we can see more information about our asset, which comes directly from our EAM system, in this case Maximo Manage, also included with the Maximo application suite. And this is a breakdown of the health score drivers and factors that give us insight into what's causing this asset's poor health. And for this asset and assets in the same group, we can see that the health score is a weighted average of open work orders, remaining useful life, and meter health. So now I'm going to scroll down to expand the predictions tab and let these graphs load. There are several predictive models built to score against incoming sensor data for our asset, and IBM Predict includes templates to help our data scientists get started building models to project days to failure, calculate probability of failure, detect anomalies, and generate an asset life curve based on group asset deployment and retirement dates. These templates include a large number of algorithms and can automatically select the one that best fits our data for the optimal outcome. Watson Studio and Watson Machine Learning are both included with the Maximo application suite, and both of which our data scientists can use for building, training, and maintaining predictive models. So in the case of our asset, our model tells us that it is projected to fail in 2 days, plus or minus 2 days. Depending on the richness of our failure history, our data scientists can build predictive models for specific failure modes, and we can select those failure modes within the widget to see the projection for each, and that would be at this drop-down menu. So there may be more failure modes for a different asset. For our specific pump, the failure mode is the pump has stopped. Also in the widget, we get information about our training data to help us decide when a model should be retrained. So these are the dates of our training data. And the failure probability widget can show us how different failure models impact our predictions. For example, it might show our asset has a blank percentage probability of failure in the next blank months due to these contributing factors. Our data scientists can build specific models for different time periods, and just like the failure models, we can look at the results by making different selections with our widget. So we can scroll to the failure probability trend card, and we can change out the different time frames that we want to look at. The factors that contribute to failure show which factors from our training data impacted failures the most, giving us an indication of what may lead to future failures. And for us, a lot of it is this velocity, this increased velocity that might be causing the pumps to fail. Our anomaly detection model creates a threshold based on history, and we can see when our asset exceeds that threshold in our widget. So the threshold can be shown as a 9.6, however, we're at a 12.8. And it can also show a trend throughout. And I'm also going to scroll down to asset timeline and expand that card. So we can see that I have a predicted failure right here, and that will occur before our next planned maintenance, which is this line on the graph. Other information on the chart, like past work orders and inspection, provide valuable insight into our asset's history and may support what kind of action we take. While each piece of information gives us insight into the state of our asset, all the information together gives us a richer view and helps us make a data-driven decision on how to address this asset. And so now I want to take action. And once I decide what action to take, I can do it immediately from the top of this page. So I'll scroll all the way up. And in the upper right corner, I can click the drop-down menu for actions. I can create a service request, a work order, recalculate a health score, or edit source asset record. In this case, I'll edit the source asset record to adjust this next scheduled maintenance to avoid a potential failure before the scheduled maintenance, and then therefore avoid unplanned downtime. And this brings me out to manage in order to do that. And I'm not going to actually do it for this pump, but once that's done, I would go back into predict and mark this as addressed so that it is moved out of my queue like that. I'm going to leave it unchecked. Replacing a low dollar O-ring could save thousands of dollars in capital costs, preventing the pump from failing by vibrations. I can also use this type of information to ensure that we aren't over maintaining their assets. And as we address all of the pumps in our work queue, we can reduce the alerts and service requests and monitor. And this information can also be valuable for capital planning purposes. And that concludes our last exercise working with the Health and Predict Lab.